Hi. All right, so we talked at length about rays, points, planes, and all the fun sort of geometry stuff in person. But now let's make sure we're doing okay with all of these problems. Of course, now Miss Winters is calling. Hi, Miss Winters. I'm currently recording a class. Is there anything you want to say to the class? Well, no thumbs went up, I'm sorry to say. They can't hear you. Okay, I'll call you back when I'm done with the video. Okay, bye. Sorry about that. Laugh out loud. Of course you all love math more than science. Whoa, is there ever a question? No. All right, so here's what we're gonna do. We're gonna take a look at 1.2, just to make sure we're all on the same page. All right, so you already done these problems. That is the expectation. And now we are double checking it, and then we're gonna go into some extra examples. So you're gonna do some pausing of this video, no big deal. All right, pause the video. Make sure you're done with the problems. I'll get back to you. I'm back. All right, so two opposite rays in here. Well, opposite rays are rays that are going opposite directions from a common center or a common point. So the only place that we have here that meets that criteria, well, we have opposite rays here, but we can't really describe this part, this line right here. I know it's hard to see on this little video, but oh well. All right, but we do have opposite rays coming from point C. So two opposite rays in this case would be CB, remembering that the center point has to be listed first, the point on the ray is second, and we have to use the correct symbol to show that it is starting at C and moving towards B. Well, so we've described this ray right here. Well, we need to describe the other ray as well. Well, we're starting at C again, and we're moving to point D. And we have to have our little arrow. Okay. We need to find a point on BC. Well, that's not helpful. Let's assume that we need a point on the line BC. Well, that's going to make life much easier. So without that line, we don't know if we're talking about a line segment or a line. And BC right here doesn't have any point in between B and C, so I cannot give a point on BC, the line segment, but I can give a point on C, other than BC, of course, and I could say B or C, right? In this case, D is along that line as well, so I can say point D. Finally, the intersection of plane N and T, well, here's plane N, or T, plane N, it meets along line BD. And I have to use the line nomenclature. All right, draw, number 4, draw a ray with an endpoint P that passes through point Q. So we have a ray. Personally, I prefer aquatic rays because they are so graceful when they swim. How about you? Anyways, and point Q. And there we go. Not too tough, but that way you can check your work. All right, so today we're going to be looking at how to construct congruent segments. And I love this because we're actually going to use a compass. So I'm going to pull up my weapons of math instruction. So we have a compass, and compass's bestie is a ruler. Aw, yeah. All right, so we can go ahead and get started. So to draw a segment that is congruent, the first thing I need is a line segment. Now, congruent means same size, same shape, but it does not mean that it has to be in the same direction. We just are looking at the magnitude, the distance from one point to the other. So to do that, I'm going to put my metal tip at the K, best letter ever, and then I'm going to rotate the compass so that my pencil is on F. Then I'm going to take that, I'm going to make a point on my new line. And then, so I know the distance from K to F is equal to the distance from here to here. Let's use moving. All right, so then all I have to do is erase. That's good enough for government work. And there we go. So here's point L, here's point W, and it is congruent to line segment L, or WL is congruent to line segment KF. Not too bad. Perpendicular bisectors are finding the midpoint of a segment. So we are going to do something very similar. We're going to place the metal compass point on T. We're going to open it past what I would imagine would be the halfway point between W and T. I'm going to open it a bit. And I'm going to make an arc on both sides, above and below the line. Then I'm going to, without allowing my compass setting to change, it has to stay the same, I'm going to place the metal point on the W, point W, and I'm going to, check that out. They don't cross. Well, that's not the end of the world. I didn't do anything wrong, I just didn't complete the problem. All I need to do is put the metal compass point back on T and extend my arc, no big deal. Then, using my straight edge, connect the 2 points of intersection, which means this blue line intersects the black line at a right angle, which makes it perpendicular. This is the bonus part of the video. But it also bisects W and T, which means, let's call this O, which means that line segment TO is congruent to line segment OW. Pretty cool, and yes, that's the congruency symbol. All right, great. Moving on, shall we? All right, so here are some examples. Before we go through the examples, I really expect you to read through the chapter and read the examples that are in the book. So pause the video now, and then come back, do these problems, and see if you got them right. So you are pausing now. And now we're back. Okay, maybe I didn't give you enough time. So I'm going to get rid of this, so at least put it to the side. Okay, so find each length. So AC, well, it's on a number line, makes life really easy. So from -2 to, well, that's clearly 3. That's only 3. That's a backwards 3. 3 units long. Remember, length does not talk about the direction. It doesn't matter if we're going left or right on the number line, bigger or smaller. We just want the magnitude, the distance. Right? BC, well, that's just from 1 to 3, well, that's 2. Okay. 1, 2, 3, 2. Okay, I think we did okay. I have troubles counting sometimes. Okay. All right. Construct a congruent segment. Same basic idea. I'm going to take my favorite ruler and compass. I'm going to start here so I don't have to erase on that side. That's erasing is a good thing. So then I'm going to place the compass point on M, rotate the compass so that we're along this line. Okay. Let's call this A, super original. Let's call this B, even more original. And so now we have a congruent segment. All right. Question A and B. G is between F and H. FG is 6. FH is 11. Find GH. So G is between F and H. So that means I have a line segment. We have F and H. Do I expect you to draw it even if you know the answer? Yes, I do. And we know that G is between them. And we don't know where. It might be right in the middle. It might be off to the side one way or the other. Either way, it doesn't matter. And we know FG is 6. FH is 11. Warning. Oh, FH is 11. That's GH. Oh, no. So we know that this distance here is 11. Well, 6 plus something is 11. Well, so we have 11 is equal to 6 plus another number. So that has to be 5. Oh, my drawing is pretty close to scale. Excellent. Find, M is between M and O, find NO. No! Okay. So this is a nice little algebra problem, isn't it? Same basic idea. We know that this plus this length is going to equal this overall length. So we know that 5x plus 2 has to be equal to 3x minus 5 plus 17. Sorry, I went over a little bit. All right, so let's subtract 3x, subtract 3x, and I get 2x plus 2 is equal to negative 5. Well, what's negative 5 plus 17? It's 12. Well, minus 2 minus 2. 2x is equal to 5, so x has to be equal to, sorry, that's 10. I got ahead of myself. So x has to be equal to 5. All right, so that's not what we want to know. We want to know the distance from N to O, from N to O. Okay, 5 times 5 is 25. 25 plus 2 is 27. So I believe it's 27. But I want to just double check because I've had a couple hits to the head and my math might be a little off. So let's figure out this one. So 3 times 5 is 15. 15 minus 5 is 10. All right, so that's 10. 10 plus 17 is 27. We checked our work. Yeah. Finally, the map shows the route for a race. We love races. You are at X because X marks the spot. 6,000 feet from the first checkpoint, C. So that's 6,000 feet. Okay. The second checkpoint, D, is located at the midpoint of C and the end of the race. So this is equal to this, which means if I call this, I don't want to call it X, because that point is X. Let's call it D. We already have D. Let's call it M. If this distance is M and this distance is M, that means it's the same. They're equal, right? So how far apart are the checkpoints in feet? And the race is 3 miles from here to here. It's 3 miles. It's a 5K minus a little bit because, you know, everyone loves running a PR, so sometimes they'll just knock off that 0.1. Okay, so feet. All right. Well, I'm going to pull up my calculator because we have this in feet, this in miles. I need to figure out how many feet are in the race. Now, thank goodness I live in Colorado and Denver in particular, because I would never remember this under normal circumstances. A mile is 5,280 feet. And I have 3 of them. So that means the total race is 15,084 feet. All right. So here we go. We know that 6,000 of it is already taken into account, which means this piece here has to equal 9,840 feet. Well, it's broken into 2 equal. So divided by 2, and so we know that this is 4,920 feet. This is also 4,920 feet. And there we go. We have the distance between each checkpoint. All right. So you have your homework posted on Schoology. You have your examples. You've had a chance to go through them. So if you have any questions, please feel free to contact me. You know how to do it. or you can wait until I see you in person. Now, if this isn't during COVID school and I'm using this in years, subsequent years, just raise your hand and I'll just come right over. Okay, see ya.